Hello viewers, in today's class we are going to solve yet another problem from homogeneous differential equation, right? So here we have to find the general solution of this differential equation, that is x dy over dx is equal to y minus x sine y over x, right? So now here what we will do, as we see that if we divide both sides by x, then we have dy over dx is equal to y over x, and here this x get cancelled, so we are left with sine y over x, right? Now we see that this expression or this differential equation, it falls in the category of homogeneous differential equation, right? And such equations are solved by making the substitution, that is y over x is equal to v, where v is some function of x, right? So now we can write y is equal to vx, and here dy over dx is v, then derivative of x is 1, then we have x, then we have dv over dx, right? So what we have done over here, we have substituted y is equal to x is y over x is equal to v, so y is equal to vx, right, where v is some function of x, and then differentiating both sides, and here applying the product rule, we have this expression. So now dy over dx is equal to v plus x dv over dx, right? So now let us substitute here dy over dx as v plus x dv over dx, and v for y over x, right? So therefore this equation, it now becomes v plus x dv over dx, and here we have v, and here we have minus sine v, right? Now this v and this v get cancelled, and we are left with x dv over dx is equal to minus sine v, and now we see that this differential equation it reduces to the variable separable form. So here the variables are v and x. Now we can separate them. So we have dv over sine v, and here we have minus dx over x, right? Now we can rewrite this equation as dv over sine v plus dx over x is equal to 0, right? Now 1 over sine v can be written as cosecant v, and here we have dx over x is equal to 0, right? So 1 over sine v is equal to cosec v, right? Now if we integrate both sides, we have this expression, and here we have the constant of integration, right? So integrating both sides will get this expression, where c is the constant of integration. Now here we have to make use of an important result, that is integral of cosec v is given by log of cosec v minus cot v, right? So this is the integral of cosec v. So here we'll use this result. So we have log of cosec v minus cot of v, and here we have the integral of 1 over x is log of x, and here we have c, right? Now combining these two terms, because we know that log of m plus log of n is equal to log of mn. This is the product rule for logarithms. So we have now log of x times cosec v minus cot v, and here we have the constant of integration as c, right? Now we can replace this constant of integration c by some other constant, say log of c1, right? So here we can take log of c1. Now we see that both the sides carry the log, hence taking the antilog, we can write x times cosec v minus cot v is equal to c1, right? So c1 is a constant. And now again replacing v by y over x, we have x times cosec y over x minus cot of y over x is equal to c1, right? So therefore we can write this expression as cosec y over x minus cot of y over x is equal to c1 over x, right? So viewers, this is the general solution of this given homogeneous differential equation. So this is how we solve this problem.